So the next question, problem number 2, is the question is given. You can see that the question is given in terms of the text. That means the data will be given. Looking at the data, we will have to draw the arch based on the given data, right? So let us quickly read out the question. The question says a three-hinged parabolic arch. That means we know that this is a parabolic arch which is having three hinges. It is hinged at the supports and at the crown. So all the three hinges are present at the supports and the crown respectively. And it has a span of 24 meters and a central rise of 4 meters. That is, the maximum rise of the arch will be 4 meters. It carries a concentrated load of 50 kilonewton at 18 meters from the left support and a UDL of 30 kilonewton per meter over the left portion. So determine the moment, thrust and radial shear at a section 6 meters from the left support. So the problem is pretty simple. It is same as problem number 1, but here the data is given. We will have to draw the arch accordingly. So step by step we have to draw the arch. So when you draw the arch, it looks something like this. All right. So now we can see this is a three-hinged parabolic arch having hinges at A, B and at the midspan. The total rise is 4 meters. There is a point load acting at 50 kilonewton, that is at 18 meters from the support A, and also there is a UDL acting at the left half of the span. So this is how you draw an arch with the given data, right? So for this, what we have to do is we will have to find out the moment, thrust and radial shear, that is normal thrust and radial shear at 6 meters from the left support. All right, so let us go on finding the data, right? So now taking moment about the point B, we are finding the support reactions. Once we take moment about the point B, we will have three forces that create the moment. One is the 50 kilonewton load, another one is 30 kilonewton load, and another one is this force VA. So all these three forces will be responsible for creating moment when you are taking the summation of moments at point B is equal to 0. So now you arrive at this solution where VA will be equal to 282.5 kilonewton. Once you subtract this 282.5 from the summation of vertical forces, that means 30 into 12 plus 50 minus 282 if you are doing, then you will get a value of 127, which is nothing but the value of the support reaction VB. So VA will be 282.5 and VB will be 127.5 kilonewton. Next, we will take moment about the crown C to find out the horizontal reactions. So if we take moment about the crown C equal to 0, then we will find out the moments with reference to this side of the arch, that is right side of the arch. So the forces that are involved are VB, horizontal reaction H, and also the 50 kilonewton load. So now because of all this, we are multiplying the perpendicular distances with reference to this crown, and we are arriving at a value of the horizontal reaction 307.5 kilonewton. So all we need to do is the value of VB we have already found out in the previous slide. So H is unknown and 50 into 6, all the distances we know. So all that we need to do is cross multiply and make sure that we are getting the value of H on one side, right? So now we are going to find out the value of moment at 6 meters from the left support. So you can see here 6 meters from the left support, we are calling this rise as YD. So if we are calling this moment at 6 meters as YD, so the support reaction will be VA. The force we are going to take the moment of all the forces that are going to act at this point 6 meters. So that will be VA multiplied by 6 and the horizontal force multiplied by this distance YD, and also this 30 kilonewton per meter UDL over a span of 6 meters, that is 6, and the point of action will be half of this, that is 6 by 2. That is why it is 30 into 6 square divided by 2. So now we will have to find out this value of YD, because if you have to find out the moment, you will need the value of YD. You will already know the value of H and the V values. So if we find out the value of YD, we can easily find out the moment at 6 meters, right? So we are going to find out the value of YD at 6 meters using this particular equation of the parabola, right? So now we are going to find out the value of YD. So 4H is the total rise of the arch is going to be 4 meters. X is the place where you need to find out the unknowns, that is the value of y. So x will be equal to 6 meters, and the total span of the arch is 24 meters, that is the length of the arch, 24 meters, and x is again the value where you require the unknowns. And we are on substitution, you are going to get this value of yd as 3 meters. So just by looking at this, you can know 4 meters and this is 3 meters. So the highest value will be 4, and this should obviously be less than that. If you are getting more than 4 at any point of time, there is some mistake in the calculation of the value of yd. So now substituting all the values in calculating the moment. So the moment at 6 meters from A will be 232 kilonewton meters. And we are also going to calculate the vertical shear at D. That means the value of V at D. So I'm going to call this point as D. So VA is the vertical force and 30 is the downward force, vertical reaction and downward load. So there are only two loads that are acting within this 6 meters span. So we are going to take the summation of those two vertical forces. VA is 282, we know, and this is 30 into 6. So we are going to arrive at a value of V is equal to 102.5 kilonewtons. So now we are going to find out the value of theta by using this equation of theta. By differentiating this equation of the parabola, we are going to find out this equation of theta. So once we calculate this equation of theta, we will be getting, substituting all the values, that is respective h and x values. Again, the value of x here is 6 meters, where we are asked to find out the normal thrust and radial shear values. All right. So now tan theta is equal to 4 is as it is, h is the rise of the arch, L is the length of the arch, and x is the point where you require the unknown, and L is again the length of the arch. Right. So now we are arriving at a value of theta is equal to 18.435. We are going to substitute these values. H is going to be as it is, the horizontal reaction. V we have just calculated, and the value of theta also is known. So all the three unknowns can be filled here. Once you substitute the values and calculate, you are going to arrive at a solution of n is equal to 324.133 kilonewtons. And also in the calculation of radial shear, we have to calculate V is equal to S is equal to, that is radial shear is equal to V cos theta minus H sin theta. Once you substitute the values, you can notice that the radial shear will be equal to 0.